Hello, and welcome to building the STELLA 1.2 Remote Sensing module for the STELLA 1.2 base module. This is the updated version. Okay, so we'll start out with the tools you'll need. These will be some familiar ones: solder iron, breadboard, snips, wire strippers, multimeter, hobby knife, tape, pliers, marker, and safety glasses. We also suggest a fume extractor as well. Okay. And to note, this module will only work on the latest STELLA 1.2 base module release. We have really upgraded the hardware and the software and the build a bit after successful test of the original STELLA 1.2 base module. Okay, so for 3D parts that you'll need the 3D part hood. You can see there's a little stringing there. I'm going to have to clean it up a bit. So we're going to clean these parts off. You got some breakaway pieces and all that. This is purely a remote sensing module to start out here. Okay, so we replaced the LiDAR with an ultrasonic rangefinder. After talking with the LiDAR manufacturers, they recommended it because of the sunlight interfering with the wavelengths for the LiDAR. So we went with ultrasonic rangefinder instead. Okay, here are the parts you will need. And you can get most of these parts, especially if you built one of the other ones, right off of the board here. And we did solder these in, so you'll need a half-size proto board, 3 and 4 pin couplers, a triad, thermal sensor, humidity sensor, ultrasonic rangefinder, 0.1 UF capacitor, and 20k ohm resistor, as well as a 10k ohm resistor. There we go. So, and this will be a more robust module than the other one, as these are put together via soldering and not just the connectors. Okay, so I go ahead and mark my A30 corner here, because for this one we're doing that, and then I start cutting the traces for the couplers. Okay, and getting out the little segments there. And be careful not to cut your fingers. So cutting traces 30 and 29 A, B, B, C, and C, D, as well as I, H, and J, I. I like to do 2 or 3 swipes first, and then dig out the segments to really see if I can get those segments out. And then, of course, at the end of this, I will go ahead and test and make sure that those traces are cut. So, get my multimeter here, switch it to ping mode, and go ahead or beep mode, and see if any of them are still there. So I found one, and found a bridge, an unwanted bridge there, and so went in there, and I'm checking out the traces at the ends too, just to make sure. So I might check out a few over here as well, Okay, so now we're going to add some couplers. And just like the base module, you're going to get your couplers, and these are going to be the pinned couplers, so these are not going to be the flat type. Okay, use your aligner, and you hook them up A30, B30, C30, D30 with the 4-pin, and for the 3-pin, J, I, and H. Okay, and then I like to put a little tape on there, make sure they're sitting flat, make sure they're stable in the aligner. Okay. There we go. And I put a little bit of backing tape there so it doesn't move position that easily. Go put it a little flux, and then we will solder these on in. Clean off our solder iron here. There we go. Don't need a ton of solder, just a bit. Okay, looking good. And I do like to test for bridging, because this is, generally speaking, if there was going to be some bridging, this would definitely be one of those instances where it might happen. Easiest. Alright, now we're going to add the headers. So we add the headers first. Okay, and this is a relatively simple build, and it is a lot of fun too. Not quite as fun as the main board, but and I had the honor of preparing the order of this. So we put the 6 header pins in from G1 to G6, from C1 to C6, and 2 other 6 header pins from G11 to D11 and G26 to D26. And you do need to pull out the pins in between the ones from on G26 and G11. So you pull out the middle pins there, and you just have the upper 2. There we go. And we fit those right in. Okay, and I'm going to tape them down. Alright. Oop. Dropped one. Okay. Alright, let's make sure those are taped in so they don't have the best alignment, so, and especially the 2-pin ones can be kind of finicky. So I like to put like a dot of solder on just one of the pins for the most part to start, and that way I can adjust the alignment on the fly here. Okay, and this is a bit of an advanced technique, so you got to be very careful with the solder iron if you do this. Alright, so I'm holding that pin, and I'm also very careful to keep my finger away from the pin that is getting heated up. Okay, but I can feel when it is flush, when the headers are flush with the board and straight, and then I go ahead and make sure that it's all straight and flush with the board. And then I go ahead and solder in the rest of the pins. Okay. So there's many different techniques to do this, of course. And I am not a professional by any means as far as soldering goes. So I have picked up a few tips and tricks, and I feel like I get better each one of them, but then sometimes, you know, you forget, and you're like, oh yeah, I should have done it this way. And you'll notice that if you see the conversion video, because in the conversion video, and when I'm talking about the conversion video, I'm talking about the conversion from the old 1.2 Stellas to the new 1.2 Stellas, which is just trimming a few wires and all that, but some of them are a little bit difficult to get to. And it was not my best showing. So now we're going to add our discretes. Okay, so these are going to be our resistors and capacitors. Okay, and this has a really fun, fun with the resistors coming up here. So we're going to put our capacitor in first. Okay, that's the 0.1 UF capacitor, I5 to I6. And then we have our 10K ohm capacitor and our 20K ohm capacitor. Okay, and so our 10K ohm resistor from E to F28, and our 20K ohm resistor from E27 to J28, which is kind of a big leap. So I usually find some leftover either heat rep or some leftover wire insulation, and I might put a little bit on there just because I don't like the exposed wire traveling so long on my board. But you're not required to do so. So there we go. I found a little bit of leftover wire and popped it on there, so it gives a nice little sleeve. Okay. And go ahead and clean that on up. Alright, now we get to do the wiring. Okay, and so we put the headers there, and you'll see why in a bit. Basically, we need to go around the wires and manage our wiring pretty well. So we go green from J8 to SCL negative above J8, the white to J7, SDA plus above J7, orange to J29, J30, all the way to J5, and the black wire, the ground from B29, B30 to the ground below A29 or A30. So that's one of the changes. Would be the ground and the power switch up, and that's reflected on the base module build as well. Okay, and so with these, I like to see if I can lay them as flat as possible as I'm putting them around the wires and all that sort of stuff. And that's because above it, there will be, for one side, there will be a rangefinder, and the other side, we're putting a humidity sensor. Alright, there we go. There's our ground. Now we're going to go from blue I-29, I-30 to I-28, so a short distance. Blue J2 to B28. Red A29, A30 to the 3 volt plus below A30. Green C29, C30 to the SCL negative above J30. And E30 to SDA plus, okay, above J30. So we're fluxed all up there. Okay, and then we're making our connection here, so we are purposely bridging those two there, making sure that they're bridged and there's no bridging in between them. So we got a little solder in between there. So what I do is use the solder iron and just sort of scrape that out a little bit. And that happens every now and again. But it's a pretty easy fix. And we're going to clean this up. Okay, test for bridging. Making sure that the connections are going through. This teeny tiny blue wire there. Just jumping from one to the other. It's kind of a tricky one because it's so tiny. Alright. This is one of my favorite wires to run because this is going to run under the triad sensor here. So again, trying to make it lay pretty darn flat because we don't want to affect the alignment of the triad sensor when we put it on. finish up the white wire. Little flux, and I'm going to solder them on. Clean that on up. So if the wire's a little too close, you know, might take another second to make sure that, there we go. We're going to put a little bridge there in the E1, just for fun. Okay, and we're going to do a little bit more wiring, but we're going to be doing the grounds and the power. So we got black from A5 to the ground below it, A8 ground, A11 ground, A27 ground, A6 to the positive under A6, and then A7. No, I actually kind of enjoy this. Normally I'd be listening to some music and having a good time putting all these wires in. And I do like to use some of the clipping sometimes. No point in wasting a bunch. Flux it on up. Clean your board. Now we're doing the green from E4 to the SCL negative above J2, and white from E3 to the SDA plus above J1. And again, making it pretty flat. And I might not put these all in the exact same hole, except for the ones to the headers. So if I do the SDL or the SEL and the SDA, so they're different as long as the white and the green go together, you should be okay. But again, make the wires pretty flat, as you will be putting some modules on top. And you don't want any misalignments. There you go, clean up the board. Okay, now we're going to add the triad and thermal sensors. I like to, you know, there's so you put the triad on here and it should fit on those four. Okay, and you definitely want to make sure that the singular sensor is facing towards the couplers, so exactly in this particular type of position. And right now I'm only soldering the 3 header pins in there and leaving the ground open. Okay, and then I'm going to pop this thermal on here, so make sure and push it through the 3D printed thermal spacer. Okay, make sure the little tab, you'll see a little tab on the thermal, make sure that is faced again towards the couplers. Okay, and I make sure it's pushed down very well so that it's sitting flush with the 3D spacer and the board. and then I solder it on in. Okay. And the triad we will wire up in just a bit. So you can either start wiring it before you put it on the header or after. I like to do it after, so now we're doing a black ground wire from J6 to the ground below A9. And the reason I saved this for last is because it's got to this point is because it's got to bend a little bit around the thermal. And I find it's just a lot easier to do that after I put the thermal on there. And so you just sort of bend it a little bit around it, okay, and you can pretty much push it down, and so that it's really not sticking up high at all. All right, now we're going to add the rangefinder and the humidity sensors. And so the rangefinder is going to go from G1 to G6, okay, and it's going to go on the last, and then you have the humidity sensor going in. And you might have to, sort of angle it a little bit to get it underneath the thermal sensor, spacer, but it's not that hard. This area is a little bit tighter, so I like to tack it from the top a bit. Make the solder iron a little bit more straight up and down, and those little tight gaps, so that I'm not pressing any of that hot iron onto any of the plastics as best I can. Okay, and just touch it up and make sure that the solder connected real well. There you go. Okay, and now we get to wire up the triad. And this is pretty fun. And it's pretty relatively simple. Like I said, there's a few different techniques you can do this. So you're going to do the black ground wire to ground, and the red to red, green to green, white to white. You don't need to do it exactly at those particular numbers up there. So if you have a little bit of extra length of the ground or whatever, you can trim that down and put it down. But you do want the wire profiles to be sort of small, so you don't want them to be up real high or anything like that. And you want them to be out of the way of all the other sensors as best as possible. So there's the ground, and so you can see I made a little loop there, and I put it around the ground wire, and then I put the solder on the ground wire and loop. Okay, so this one I'm putting some solder directly onto the solder iron and sort of feeding the wire in. So I didn't make a very, very long wire there, stripped portion of the wire. I made it kind of tiny because it does hit, it doesn't go that far in. And so you pop that in there and you put the hot solder on there, and you got to do it in a relatively good time because you don't want the solder to sit there and boil the entire time. So there we go. And then possibly just a touch more solder there. Okay. And so if you're not comfortable with that technique, another one is to pre-solder some of the wires onto the triad. Again, be careful doing that. So it's going to be a little bit tricky either way, but I do kind of like doing this method. And this method will come up again when I'm doing the conversion build. So it might be useful to practice. And that's something you might want to practice before actually attempting this if you're doing it. Okay, so again, green to the green trace, white to the white trace. Yeah. Just make sure and solder all these wires on in. Alright, it's looking pretty darn good. I'm going to clean it up, so I'm using some rubbing alcohol that is 90% or above alcohol for electronics. Okay. And I want to test to make sure the connections are all good there. Okay, looking pretty good. Alright, now we're going to finish the assembly, and we're going to attach the modules all together. Okay, into the 3D printed housing here. So I make sure the 3D parts are nice and cleaned. Okay, I got some of the string out and all that, and I made sure that the supports are broken off, and I clean that up just a bit. Okay, and really this is just a snap together sort of a thing, so if everything's aligned, you should have a pretty good whole remote. Thank you for joining me on how to build the remote sensing module, and happy measuring.